Hi, welcome to the video VISTA, a novel research prototype to repair web test cases developed at the University of British Columbia. Our approach uses advanced computer vision algorithms to automatically validate test cases in order to detect potential deviations from the correct behavior of the application. In this presentation, we refer to such cases as test breakages. Our approach finds potential fixes that can repair test breakages and reports them to the user. Let's start with a quick overview of web testing. Our tester, hereafter named Bob, wants to test his web application efficiently. To this aim, he implements an automated test suite which automates the set of manual actions that he would otherwise perform manually. Our Bob is happy because test automation allows him to save precious time and resources. Let's see a more detailed example. In this web page, Bob wants to test the correct behavior of the login form. To this end, he writes an automated test script, for instance using the Selenium framework. Our example highlights the actions performed by the script on the user interface of the application. First, it types the username, then it types the password, and finally it clicks on the Submit button. At last, the script verifies by means of an assertion that the correct username is displayed on the page. We have implemented a running version of such a script in the Java language and the Eclipse IDE. Bob has now tested and verified the correct behavior of the login form of his web application. When a new version is implemented, Bob wants to verify that the most recent code changes have not adversely affected existing features. This approach is called regression testing. In practice, the test suite is re-executed on the new version of the application to ensure that already tested functionalities still work correctly. The applicability of automated test suites for regression testing is unfortunately undermined by the occurrence of breakages. A test breakage occurs when the test stops or raises errors that do not pertain to the presence of bugs, but rather due to the test losing the synchronization with the application under test. The most common cause of breakages is due to fragile web element locators. Let's see an example. In this case, we execute the same login test on the new version of the application. We can notice that the text execution stopped and JUnit reported an error. Bob must then manually inspect the test and the application to find the repair. In this case, the responsible for the breakage is the login button that can no longer be located by the web elements locator. So the tester captures a new locator to be used in the test. Then the test is re-executed. We can notice the occurrence of another breakage. Bob is then required to find another repair for the test. Repairing tests is a time-consuming task because the tester must inspect the error message and jump back and forth from the source code to the interface in order to understand the root cause for the breakage. We believe that most of this manual effort can be saved using differential testing and computer vision techniques. Our tool VISTA automatically validates the test cases as they execute. As breakages occur, it automatically analyzes the GUI and the DOM of the application to find potential fixes, in the same way as testers would do. VISTA works in two steps. In the first step, the approach captures information about the dynamic visual execution of the test cases, associating each test statement with its visual information. In the second step, VISTA runs each test case on the new version and makes use of the visual traces to validate each test statement. On the detection of breakages, our approach finds potential repairs. At the end of the process, the approach outputs the validated test suite and the list of repairs. The manual effort required is significantly reduced in comparison to Bob carefully verifying each executing test and manually searching for fixes as breakages occur. Let's see our tool in action on the same login tests shown before. In the first phase, we run the correct version of the test so that VISTA could capture visual information about the correct execution. We can see that the elements which the test interacts with are highlighted by VISTA. The dynamic visual trace is made persistent on the file system, allowing testers easy inspection. Annotated screenshots are created so as to show the path exercised by the test on the user interface of the application. At last, the mapping between each test statement and their visual information is simply represented as a JSON file. We now execute the second phase of our approach, in which VISTA uses the visual information to repair the login test when executed on the next version of the application. We can see that the analysis is quite fast. By inspecting the logs produced by the tool, we can notice that the first two statements were found correct by VISTA. We remember that this test breaks when attempting to click on the login button. In short, VISTA was able to find correct repairs for the two locator breakages by using the visual information of the correct execution trace. By using our tool, testers no longer need to go back to the application because VISTA analyzes it for them and provides actionable suggestions that can be confirmed or discarded. Finally, we graphically show how the computer vision algorithms adopted by VISTA are able to match web elements visually across different versions of the same web application. As seen in this presentation, this is useful to perform effective root cause analysis, but it can also be exploited for repairing tests automatically. To summarize, VISTA can repair web tests fast and accurately, thanks to its pipeline of advanced computer vision algorithms. Moreover, our approach does not require modification to existing test suites. We have evaluated VISTA against a state-of-the-art technique called water, on a benchmark of several hundreds of locator breakages. Our empirical results show that on average, VISTA outperforms water both in the number of correct repairs and in the running time required to detect them. Thank you for your attention and happy web testing from the Salt Lab in Vancouver.